We build incredibly sophisticated machines, yet the exact second you turn this robotic arm on, its inevitable decay begins. To keep human machinery functioning, we have to intervene, constantly pouring in specialized labor and energy just to delay the friction that is tearing them apart. But for an axolotl, severe trauma isn't a crisis. Losing an entire limb is just a routine Tuesday. This amphibian doesn't wait for an external mechanic. It orchestrates a structurally perfect autonomous regrowth process from the moment the injury occurs. Our technology is designed to rigidly resist damage until the point of failure. In contrast, biological systems are designed to detect damage and rebuild. This reliance on static design is a ceiling on human innovation. True technological supremacy requires adopting the active living blueprint of biological organisms. Human engineering separates the instructions from the product, relying on distant factories or hard drives to dictate repairs. Biological integrated design, the complete architectural blueprint, is distributed locally, stored inside the very material it is meant to build. Because every microscopic cell contains the full data core, each unit of the body functions as an independent member of an internal maintenance crew. A damaged machine sits idle until an external mechanic arrives with a manual. The biological organism system reads its own internal code and begins repairs instantly. Survival and autonomous healing are dictated by this one factor, the physical proximity of the blueprint to the material itself. At the site of catastrophic damage, biological organisms initiate a frantic cellular response, signaling that the reconstruction phase has begun. These cells form a blastema, a temporary on-site manufacturing hub that the body generates precisely where the repair is needed. This hub reads the distributed DNA blueprints to guide the synthesis of raw cells into specialized tissues like bone and muscle. The process is a chronological layer-by-layer reconstruction, starting with a central bone line, wrapping it in muscle, and finally sealing the structure with skin. This cellular assembly line reconstructs a functional replica of the original limb. While the human body typically heals by depositing a chaotic rigid patch of scar tissue, fixing a car this way would mean the vehicle building a miniature factory on its own fender to print a new part before dissolving the factory once the job is done. Living systems don't just patch a wound, they initiate a localized manufacturing cycle that renders the original damage irrelevant. We build with passive architecture materials like steel and carbon fiber can only wear down, fatigue, or snap when subjected to mechanical stress. Living structures follow Wolff's law, which governs the behavior of instructional materials. Under Wolff's law, bone detects physical stress and remodels its internal structure to become denser and stronger in those specific high-impact areas. Mechanical stress is the destroyer of human engineering, but it is the catalyst biological organisms use to dynamically upgrade and fortify their structures. Human engineering is currently stuck on one side of an information gap, assembling dead spare parts, while the axolotl's biological system utilizes integrated synthesis. For a machine to truly self-repair, the physical material and the instructional blueprint must become the exact same entity. Biomimetic engineering is the attempt to bridge this gap by copying the localized data-driven synthesis seen in the axolotl. We see the first steps of this in self-healing concrete that seals its own cracks, and adaptive robotics that rewrite their physical code to compensate for damage. Engineering supremacy is evolving away from rigid, unbreakable strength and towards systems that thrive through dynamic yielding adaptation. If you could apply this blueprint to yourself and choose one biological superpower like regrowing lost limbs, never aging, perfect skin, or self-repairing shattered bones? Which would it be? We're building a community of like-minded individuals who love nature and healthy living. Click like and subscribe. It's free and it only takes a second, and by supporting us helps us to create more content like this for you. Thanks for watching, and don't forget to turn notifications on.